It's Yueru. I'm going to present how to detect accounting frauds in public traded US firms by using a machine learning approach. Accounting frauds usually are committed by insiders, for example, managers and controlling shareholders within the firm. If not detected and prevented on a timely basis, frauds can cause significant harms to shareholders. Frauds can also negatively affect non-fraudulent firms indirectly because they have to compete with fraudulent firms. Furthermore, due to information asymmetry between corporate insiders and outside investors, the financial market's uncertainty about the existence of frauds may hinder the normal functioning of a country's financial markets and economic growth. In real world, accounting frauds are rare and therefore difficult to detect. For example, the frequency of detected accounting frauds among public traded US firms is typically less than 1%. Even if a fraud is detected, it's usually too late and the real damage is already done by the time of the fraud's disclosure. Therefore, it is very important to develop effective methods to detect corporate accounting frauds on a timely basis to minimize the extent of damage from such frauds. Machine learning can be applied in this process of detecting of accounting frauds in public traded companies. Let's first look at the overview of how machine learning applied in this research. Because companies' management will not admit their committing frauds, the authors therefore used financial statements to evaluate. If the management team is conducting frauds, the financial statements will differ from the normal firms. Specifically, the authors transformed the raw accounting variables from the financial statements into certain financial ratios. Then, feed these ratios into a classifier or algorithm such that the machine learning algorithm could obtain a model for the detection. When new companies come, they will be converted into ratios in a similar way and fed into the training model. A final fraud or non-fraud will be labeled from the training model. Next, let's see the dataset and the features. Current accounting fraud detection research typically relies on accounting experts to identify potential determinants of frauds. For example, the financial ratios. Therefore, it is nature to design the algorithm by mimicking the behavior of human audits and adopt the financial ratios as feature for these algorithms. However, converting raw accounting data into a limited number of financial ratios results in a loss of useful information for the purpose of fraud prediction, which may weaken the detection power of the algorithm. So, in this research, authors used the raw accounting data and limit to only 24 features so that they can compare the performance between the fraud detection models and the traditional fraud detection method with the same or a similar set of raw accounting data. In addition, they labeled the fraudulent cases as 1 and the non-fraudulent cases as 0. In this research, one intrinsic property of the fraud detection task is frauds are only a minority. In this dataset, the total number of fraud cases is about 0.7% of all firm years. Such a good dataset poses a challenge to fraud detection. With that being said, various machine learning methods have been used to tackle the challenge, including undersampling the majority classes or undersampling the minority, and the algorithm level techniques. Another problem is about the performance metrics. As the main concern in this research is to accurately detect fraud from years without misclassifying too much non-fraudulent from years. In other words, we care about the both detection accuracy within the fraud and the non-fraud from years. So the balanced accuracy has been adopted to measure. After pre-processing data and some other preparations, authors first apply support vector machines approach, which usually has a good generalization performance to ensure less probability of overfitting and the accuracy of classification on future unseen data. SVM variance can handle the imbalance issue, which is one intrinsic property of the fraud dataset. With the idea of the basic SVM, which tends to learn a binary linear decision function, the biased penalty SVM has been applied in the fraud dataset. Next, ensemble method has been applied, which combines the predictions of a set of base estimators to improve the robustness over any single estimator. Due to the class imbalance issue in the dataset, authors used a hybrid ensemble method, in which the system contains M1 ADA boost classifiers. Each ADA boost contains M2 decision trees. Then they randomly undersample M1 balanced subdataset, and on each subdataset, the system trains an ADA boost classifier containing M2 decision trees. The final output label are a combination of the M1 ADA boost classifier. The result shows that in the method of support vector machines, first, we can achieve similar performance with consensus row accounting variables. Second, as expected, SVM with non-linear kernels perform better than linear SVM. Third, the certain non-linear relationships do exist in the fraud dataset. Moreover, ensemble method outperforms than the SVM approach and also confirm that row accounting variables have better discriminatability than the calculated financial or non-financial ratios. In conclusion, this research applies machine learning in business and detect the accounting frauds in U.S. public traded companies. The authors improve the detection accuracy by applying row accounting data and then employing the SVM and the ensemble method. So that's all about this research paper. Thank you.